Hi guys, I hope you are all doing well. Let's see today's question. So today's question is from the topic of differentiation, and we have been given that y is cot inverse of x raised to x minus x raised to minus x divided by 2, or I can write this y as f of x, and then they have also asked to find us f dash of 1, right? So for finding f dash of 1, first we will need to find f dash of x, which can be found out by just differentiating this function with respect to x. And once I get the differentiation of that function with respect to x, I'll just substitute x as 1, and that will give me the answer for the question asked, that is f dash of 1, right? So first of all, let's differentiate it to get f dash of x. So f of x, that is given to us cot inverse of x raised to x minus x raised to minus x divided by 2. Now we know that derivative of cot inverse of, let's say, theta, it's nothing but minus 1 upon 1 plus theta square, right? So same idea if I apply here, if I differentiate the given function with respect to x, what I get here as f dash of x, that is equal to minus 1 upon 1 plus x raised to x minus x raised to minus x upon 2 the whole square. Further, what I will do is I'll take the differentiation of this which we assumed as theta. So I'll have to take the derivative of x raised to x minus x raised to minus x divided by. So we'll solve this further, but for now we need to find the derivative of this as well as this function. So first of all, let's separately find this derivatives, and then we'll substitute these ideas in the f dash of x which we have already found. So now if we try to find the derivatives of x raised to x and x raised to minus x first, let's substitute u as x raised to x. So first of all, if I take the log function, I get log u is equal to log of x raised to x. We already know I can take the power ahead now, that makes it x log x. Now if I differentiate it with respect to x, so log's derivative we know it is 1 upon u du by dx. Here it is u into v, right? So basically I can use the idea u into derivative of v, that is 1 by x, plus log x into derivative of x, that is 1. So this gets cancelled. What you get is 1 plus log x. Now if I see the derivative of u with respect to x, that is u into 1 plus log x. U I can resubstitute as x raised to x, that is x raised to x into 1 plus log x, and this basically becomes the derivative of the function which we needed to find out, that is x raised to x. So I get the derivative of x raised to x, that it is x raised to x into 1 plus log x, right? So I have already got one derivative. Now let's try to find the derivative for other function also, that is x raised to minus x. So if I find that, let's take v is equal to x raised to minus x. Again, applying log on both sides, that gives me log v is equal to minus x log x, 1 by v into dv by dx. So if I differentiate that, I get this 1 by v dv by dx minus common x log x derivative is 1 by x and x derivative is 1, right? So log x into 1. So what I get here is dv by dx is equal to minus v. This gets cancelled. You are left with 1 plus log x. V I can again resubstitute as x raised to minus x, 1 plus log x. And I am finding the derivative of v, that is x raised to minus x. So we have also received derivative of x raised to minus x in this case. Now the f dash of x which we found out, if I substitute derivative of this x raised to x and x raised to minus x which we have received already, we get f dash of x in terms of entire derivative of f of x, and that becomes f dash of x, that was minus 1 upon 1 plus x raised to x minus x raised to minus x upon 2 the whole square, and further it was derivative of x raised to x, that came out x raised to x into 1 plus log x minus derivative of x raised to minus x, that came out minus x raised to minus x 1, right? So this was our entire idea that came out. Now, if I apply the entire idea here, a minus b the whole square, right? So it becomes a square minus 2ab plus b square. So x raised to minus 2x. The whole thing upon 4 because 2 square is 4. Further, I have this 2 divided entirely throughout. Now if I see in both the ideas, I can take out 1 plus log x common, right? So if I take out 1 plus log x common from both of these ideas, what I'm left with is x raised to x minus into minus becomes plus x raised to minus x. Now, further if I try to solve this idea, what I get is minus 1 upon this, if I multiply it here, becomes 4 plus x raised to 2x minus 2 into x raised to x, and x raised to minus x, if I write it, becomes 1 upon x raised to x. So this gets cancelled and you get 1 plus x raised to minus 2x. Now here I have 1 plus log x common and I have x raised to x plus x raised to minus x upon 2 as the entire bracket. Now if I try to further solve this idea, what I get here, okay, so basically this was also divided by 4. So if that 4 actually goes into the numerator, what I get here is minus 4, the whole thing upon. So this, if you see, it becomes 4 minus nothing is left. So here only you have 2. So 4 minus 2 is plus 2. So if I write it, it becomes x raised to 2x plus 2 plus x raised to minus 2x into 1 plus log x, x raised to x plus x raised to minus x upon 2. Now, I can cancel this 2 first because it's a multiplication. 2 ones are, 2 twos are. So we have minus 2. Again, I can write this as x raised to 2x plus 2. 2, if here nothing is there, means 2 is multiplied with 1, right? So I can write this is 2 into 1, or I can also write it as 2 into x raised to x into x raised to minus x, because that is nothing but the product is actually 1, because this will cancel each other. Plus x raised to minus 2x multiplied with 1 plus log x into x raised to x plus x raised to minus x. Further, minus 2 upon. This becomes a square plus 2ab plus b square. So I can write this as a perfect square, x raised to x plus x raised to minus x the whole square. And this is 1 plus log x multiplied with x raised to x plus x raised to x. What I can do here is I can directly cancel this idea with one of this because there are two present. What I get finally is minus 2, 1 plus log x divided by x raised to x plus x raised to x. So this is our f dash of x, but I need f dash of 1, right? So I'll put x as 1 here. So if I put x as 1, what I get the answer for the question? That is f dash of 1. So f dash of 1, I'm just putting x as 1 here. It makes it minus 2, 1 plus log 1 upon. This becomes 1 raised to 1 plus 1 raised to 1. So this becomes minus 2, 1 plus log 1, as you know, it is 0. 0. Here 1 raised to 1 is 1. Plus 1 raised to minus 1, that is also 1 upon 1 raised to 1. So that's also 1. So you get minus 2 upon 2. So this gets cancelled. You get answer as minus 2. So the answer for the question which is asked to us, that was f dash of 1, that came out to become minus 1, and that matches with our option A. So the answer for the question that was asked to us came out to become option A. I hope you have understood how to solve this kind of questions where differentiation is involved. So this was a pretty easy question. You just needed to find f dash of x and then put x is equal to 1 to get the answer for the question asked. But the difficult part in this question was to find f dash of x that involved differentiating first cot inverse of theta and then also differentiating and finding out x raised to x as well as x raised to minus x separately. Once you get that, just substitute to get f dash of x, and once you get f dash of x, you have to just substitute x as 1 to get f dash of 1, that came out minus 1. That made our solution as option A. Okay, so I will meet you again tomorrow with the next question. Till then, you can subscribe to my videos because it takes a lot of efforts making these videos, right? Thank you.